we need to use any analytical method to find the first 4 non-zero terms of the Taylor series centered at 0 for the given function. We do not need to use the definition of the Taylor series coefficients. We also need to determine the radius of convergence of this series. So the Taylor series has the form the sum of ck times x to the power of k, where k goes from 0 to infinity, and ck equals the kth order derivative of f of 0 over k factorial. So we need to find the first 4 derivative of f of x equals cosine of 2x. So f of x equals cosine of 2x. Then f of 0 equals 1. F prime of x equals negative 2 sine of 2x. And f prime of 0 equals 0. The second order derivative of f of x equals negative 4 cosine of 2x. And the second order derivative of f of 0 equals negative 4. The third order derivative of f of x equals 8 sine of 2x, and the third order derivative of f of 0 equals 0. The fourth order derivative of f of x equals 16 cosine of 2x, and the fourth order derivative of f of 0 equals 16. Well, then we get that ck equals 0 when k is odd. Then using the even order derivative, we get that c0 equals f of 0, so it equals 1. C2 equals the second order derivative of f of 0 over 2 factorial, so it equals negative 4 over 2 factorial. C4 equals the fourth order derivative of 0 over 4 factorial, so it equals 16 over 4 factorial. And C6 equals the sixth order derivative of f of 0 over 6 factorial, so it equals 64 over 6 factorial. Then the Taylor series for f is the Taylor series for cosine of x is cosine of 2x is 1 minus 4x squared over 2 factorial plus 16x to the fourth power over 4 factorial minus 64x to the sixth power over 6 factorial, and so on. And it equals the sum of negative 1 to the power of k times 4 to the power of k over 2k factorial multiplied by x to the power of 2k, where k goes from 0 to infinity. Well, now we need to find the derivatives of f of x equals to sine of x. We get that f of 0 equals 0, f prime of x equals 2 cosine of x, then f prime of 0 equals 2. The second order derivative of f of x equals negative 2 sine of 2x. Then the second order derivative of f of 0 equals 0. The third order derivative of f of x equals negative 2 cosine of x. And then the third order derivative of f of 0 equals negative 2. The fourth order derivative of f of x equals 2 sine of x. Then the fourth order derivative of f of 0 equals 0. The fifth order derivative of f of x equals 2 cosine of x. Then the fifth order derivative of f of 0 equals 2. the sixth order derivative of f of x equals -2 sine of x, and then the sixth order derivative of f of 0 equals 0, and the seventh order derivative of f of x equals -2 cosine of x. Then the seventh order derivative of f of 0 equals -2. So we get that ck equals 0 when k is even. When k is even, then c1 equals f prime of 0, so it's 2. c2 equals c3 equals the third order derivative of f of 0 over 3 factorial, so it's -2 over 3 factorial. c5 equals the fifth order derivative of 0 over 5 factorial, so it equals 2 over 5 factorial, and c7 equals the seventh order derivative of f of 0 over 7 factorial, so it equals 2 over 7 factorial. So we get that sine of x, it's not sine of x, what was it? It was 2 sine of x. 2 sine of x equals 2x minus 2 over 3 factorial x cubed plus 2 over 5 factorial x to the 2 over 5 factorial x to the fifth power minus plus 2 over 7 factorial x to the seventh power, and so on. Then now to find the Taylor series of the given function, we need to add these two Taylor series which we have found. So we get that f of x, which equals cosine of 2x plus 2 sine of plus 2 sine of x equals 1 minus 4 over 2 factorial x squared plus 16 over 4 factorial x to the fourth power minus 64 over 6 factorial x to the sixth power, so on, and plus 2x minus 2 over 3 factorial x cubed plus 2 over 5 factorial x to the fifth power minus 2 over 7 factorial x to the seventh power, and so on. Then this equals 1 plus 2x minus 4 over 2 factorial of x squared minus 2 over 3 factorial of x cubed, and so on. So these are the first 4 terms of this Taylor series, and now we need to find the radius of convergent. We will use the ratio test, and we get that r equals the limit of the absolute value of -1 to the power of k plus 1 times 4 to the power of k plus 1 times x to the power of k plus 1 over k plus 1 factorial, and this whole thing is divided by the absolute value of -1 to the power of k times 4 to the power of k times x to the power of k, and this whole thing is divided by k factorial, and k approaches infinity. Then this equals the limit of absolute value of x to the power of k plus 1 over the absolute value of x to the power of k multiplied by 4 to the power of k plus 1 times k factorial over 4 to the power of k times k plus 1 factorial, and k approaches infinity. Then this equals the absolute value of x multiplied by the limit of 4 over k plus 1, where k approaches infinity. Since k approaches infinity, then 4 over k plus 1 approaches 0, then this equals 0. So we get that the radius of convergence equals 0. Oh, sorry, this is not. So we get that this equals 0. So that means that our series converges absolutely for all x, and the radius of convergence equals infinity.